All right, well, welcome back to this discussion about the law of signs, in particular, the ambiguous case. And we continue that vague topic. And in this video, we will walk through examples of those comparisons that are necessary when we have an SSA triangle or an ambiguous case of the law of signs. Let's jump in. Here is an example. We're given triangle ABC where the measure of angle A is 43 degrees, side A is 81 centimeters, and side B is 62 centimeters. What we want to do with this is draw a picture, determine what kind of triangle is shown, and then solve the triangle. We're going to round our angle measures to the nearest degree and our side lengths to 1 decimal place. Now, right away, if I'm looking at this, I see that little a, our side length A, is opposite angle A. That's why they have the same letter. And then side B is going to be my adjacent side that I'm given. I'm going to try to draw my triangle as close as possible to the information that I'm given. I need to draw an angle that's about 43 degrees. Okay, and I'm always going to place this in this lower left-hand corner. And that gives me a nice frame of reference. I know that 43 degrees is close to 45 degrees, which is about half of a 90-degree angle. Okay, and so then I'm going to stretch my adjacent side out and say, well, that's about 62 centimeters. But my opposite side needs to be longer than that. So when I draw my opposite side, I want it to be longer than that to reach this base. Okay, so drawing a good picture helps me visualize what's happening. First of all, what kind of triangle am I given? I'm given two sides and a non-included angle. And if that's the case, I've got an SSA case. It means law of signs, but be careful. So now compare that opposite side length to the adjacent side length. And notice that the opposite side is greater than the adjacent side, which means it will have to be greater than the height. Okay, if the opposite side is longer than the adjacent side, there's only one triangle that can be formed. So I'm going to go ahead and solve this just using law of signs. I don't need to worry about anything special happening. So I'm going to start like I did before by organizing my work. What do I have and what do I need? And I notice right away that in this case, I have a pair, measure of angle A, and I've got side length A, but I've got nothing in C, right? So I am going to set up my proportion, but I'm going to concentrate first on the measure of angle B. So here's remember my proportion for law of signs, and I'm going to substitute in everything I know. And now I'm going to concentrate on the left piece and the middle piece, okay? So I'm going to use this proportion and solve for the measure of angle B. I'll cross multiply and I'll get 81 times the sine of angle B is equal to 62 times the sine of 43 degrees. I'll divide through by 81 and I'll get the sine of angle B is this quotient, 62 times the sine of 43 degrees divided by 81. Now remember, I want the measure of angle B. I don't want the sine of angle B. So I need to actually take the sine inverse of this expression to get the angle measure. And when I do that, I get that angle B is about 31 degrees. All right, great. Now I have two angle measures. So since I've got two angle measures now, I can use the triangle sum theorem to find the measure of angle C. All right, so the triangle sum theorem, add the three measures together and they should equal 180 degrees. So that means the measure of angle C will be 106 degrees. Great. And that third side I can find by using law of signs again, but on the other side of the proportion. Okay, so now that I know the measure of angle C here, I'll sub that in and I will cross multiply again. So I'll have C times the sine of 43 degrees is equal to 81 times the sine of 106 degrees. Divide out the sine of 43 degrees to get C, and crunch that in my calculator to get about 114 centimeters. Now remember, when we did this before, we did a quick check and to make sure that the longest side is associated with the largest angle and the smallest side is also associated with the smallest angle. So that's a good quick check too. It doesn't guarantee anything, but you can maybe eliminate some errors that way. Let's try another example. All right, so I've got a new triangle here, and in this case, the measure of angle A is 50 degrees. The length of side A is 10 feet, and the length of side B is 20 feet. So let's draw a picture. Start with that angle measure. Draw an angle measure that's about 50 degrees. So you can draw something close to half of a 90-degree angle. I'm going to put my adjacent side right next to the angle measure, the 20 feet. And then I'm going to put my opposite side across from it. Now notice, I still have two sides and a non-included angle, so this is an SSA case. And I am a little concerned because that opposite side is shorter than the adjacent side. I need to know, is it longer or shorter than the height? Okay, so I need to do that calculation. Okay. So I'm going to find the height by multiplying this side length times the sine of angle A. So 20 times the sine of 50 degrees. And I get that my height is 15.3. So if I were to draw up a perpendicular here, it would be 15.3 feet, which means my little 10-foot side length over here is not long enough to make a triangle. And so since the opposite side is less than the height here, yeah, I can't actually make a triangle. All right, one more example. Okay, now in this one, I've kind of mixed things up a little bit because I don't want you to be in the habit of looking at your given information and assuming that your given angle is always going to be labeled angle A, and your adjacent side is always going to be B, and your opposite side is always going to be side A. So I've mixed it up a little bit. And we've got, and the measure of angle B is 40 degrees. The opposite side to angle B, which is side length B, is 54 inches. And the adjacent side is 62 inches. Okay, so this is going to be the side closest to the angle. This is going to be opposite the angle, and our angle is about 40 degrees. Okay, so let's draw a picture. Here's our 40-degree angle, and our adjacent side is 62 inches. And our opposite side is 54 inches. I'm still given two sides and a non-included angle, so this is still an SSA case. And when that's SSA, it's ambiguous. I need to be careful, all right? I first compare the length of that opposite side to the length of that adjacent side. Opposite side is shorter than the adjacent side, okay? So I really need to know, how does that opposite side relate to the height? Let's solve for the height and find out. Okay, remember the height is going to be equal to the adjacent side times the sine of this given angle measure. So 62 times the sine of 40 degrees. And I find that the height is about 39.9. All right, so I'm looking at this height is about 40 inches. And so that opposite side is greater than the height. And what that means is there are two triangles possible. And I will have to solve for both of them. The first triangle is exactly what you see here. So we're going to go ahead and solve it just like we did the first example. We are going to start by organizing our work, all right, and put everything in its rightful place. I know that the measure of angle B is 40 degrees. I know side length B is 54 inches and side length C is 62 inches. I'm looking at my proportion that allows us to solve for a second angle. Remember that I will have to solve for the angle that I have the corresponding side for. So I am going to focus on this piece here. Okay, so I've moved my work up to the top here. Let's cross multiply. 54 times the sine of angle C is equal to 62 times the sine of 40 degrees. Divide through by 54, and then take the arc sine to get the measure of angle C. Grab that value from your calculator, and you're going to get angle C is about 47.56 degrees, and we will just call that 48 degrees. So we'll put that 48 degrees in our table. Okay, so next we've got two angle measures, so let's find the third. We'll use that triangle sum theorem to find the measure of angle A. So measure of angle A plus 40 degrees plus 48 degrees will equal 180 degrees. That means that the measure of angle A will be 92 degrees. Okay, let's put that in our table. And then we can find that third side length by going back to the law of sines and applying the proportion with that middle piece. So we've got A over the sine of 92 degrees is equal to 54 over the sine of 40 degrees. Cross multiply. A times the sine of 40 degrees is equal to 54 times the sine of 92 degrees. And divide out the sine of 40 degrees. Crunch that in our calculator, and we get that A is about 84 inches. Okay, so that takes care of the first triangle. So we're going to go to another slide, and I'm going to bring that with us. There we go. So remember how we said there were two triangles? Let's talk about that a little bit. So I'm going to duplicate that first triangle over here. Okay, let's look at this diagram, and let's remember what's fixed. This angle measure of 40 degrees is fixed. This side length is 62 inches. That's fixed. And now this side length here is 54 inches, but the position is not fixed. All I know is its length. So this is one position of this side length, but we can find the other possible position by reflecting that over the height. Okay, so that's going to go this way. And if we push it over to the left side of the triangle, that 48 degrees that we found here will come with it, but it's on the outside of the triangle. I'm going to get rid of some of this stuff that I don't need. Okay, and actually, I'm going to blow up this sliver triangle so it's easier to see. So I'm going to get rid of this here in a second, and all we're going to see is just this sliver. There we go, and it's bigger. Okay, so what I know here is this angle here is 48 degrees. This is vertex C, and what I really want is the measure of this angle here inside the triangle. But that's going to be the supplement of this 48 degrees. Okay, and so I can find that by subtracting from 48 degrees, and I will find that to be 132 degrees. That's the easiest calculation ever if you know what to do. You're taking that original angle you solved for first and taking the supplement. Put that in your table. Oh, well, now your second triangle's table looks pretty darn good because it has all the information that we were given from the problem, and I've got this additional angle measure. So what do you suppose we'll do next? If you said find this angle measure here, you'd be right. You would add that 40 degrees plus that 132 degrees and our missing angle and say that that's equal to 180 degrees. So the measure of angle A will be 8 degrees. All right, now, side length A, we'll have to use law of sines again. But that's the only real application of law of sines for the second triangle. All right, so A divided by the sine of 8 degrees equals 54 over the sine of 40 degrees. Cross multiply, divide out the sine of 40 degrees, and crunch in your calculator, and we will say that the measure or the length of side A is about 12 inches. Okay, so we've got two possible triangles here, and that is about as difficult as the problems get for law of signs, an ambiguous case with two possibilities. All right, in our next video, we'll talk a little bit about using the sign ratio to help us find the area of a triangle when we don't know the base or the height like we normally do. All right, so I will see you next time.